Hello everyone, my name is Timothy Lee Grant and welcome back to another Leetcoding video. So we are continuing our path in the two pointers topic. So let's just scroll down and see what we find. Okay, so we did all three of those easies. Should we do this one? Let's do it. Let's do it. Number 160. Okay. So, number 160, intersection of two linked lists. Ooh, we have not done a linked list problem yet. The last time I touched a linked list problem was in data structures, which was what, like about 4 years ago. I think it was 4 years ago. I did it my sophomore year, and I've been out of college for a year and a half now. So, whew, okay. Mindset. Let's see if we can remember linked lists. I remember that it was a struct, and it had a next pointer, a pointer to next, and then a value. And then you can connect them from one to the other to the other to the other. Then you have a start and stop, like a sentinel on both sides. So I remember a little bit. So we'll see about this. This is interesting. This is gonna be fun. All right. So given the heads of two singly linked lists. Oh yeah, that's the other thing. They can be doubly linked, which means A1 can go to A2, which we see here, so it has a pointer here, and then A2 can go previous. So you have a previous pointer, so you can go backwards, so you can traverse both ways. But in this case, it's a singly linked list, which means we can only go next, 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 and we can't go to previous. Okay, so return the node at which the two linked lists intersect. If the two linked lists have no intersection at all, return null. For example, in the following two linked lists begin to intersect at node C1. Okay, so we're given two lists, head A and head B, right? Head A, head B. And these are going to converge at some time, maybe. It says here, if they don't intersect, we return null. But assuming that they do, okay, it comes here and they hit. They intersect. So both of them share this node. And that this is the first instance of a node that they share. Okay. So now we need to return this node. Return the node at which the two linked lists intersect. Okay? The test cases are generated such that there are no cycles anywhere in the entire linked list. Okay, so a cycle would be like if B2 comes up to, or sorry, B1 comes up to A1, A2, like this, and then it kind of just like goes around and around. Does that make sense? That would be a cycle. So around and around and around. That would mean that there was no like stopping condition. Okay. So note that the linked list must retain their original structure after the function returns. Okay. So custom judge. The inputs to the judge are given as follows. Your program is not given these inputs. So intersection value, the value of the node where the intersection occurs. This is 0 if there is no intersection. Okay, so this is just like the information that the judge criterion is going to judge, whatever. The judge will create the linked list based on these inputs and pass the two heads here. If you correctly return the intersected node, then your solution will be accepted. Okay, so let's try to think of a strategy to solve this. So, okay, if I'm at here, so I guess the brute force method, I'm trying to think of any method right now. So I have a pointer here and a pointer here. I'm going to traverse one here, and I'm going to get to this A2. Okay, then I'm going to traverse all of these until I get to the end and see, is A2 part of this list, this chain? No, it's not. So then what I'm going to do is I'm going to go from A2 down here to C1. Then I'm going to start at the beginning here and go Oh, C1 is here, and I can return that. So that seems like the brute force method. First off, let's actually try to code out the brute force method, because honestly, recently, I've noticed that I have an issue where I can think of an algorithm. I can have this algorithm in my head, but it's very difficult for me to actually express it in code. Okay, great. So let's get some practice. Let's write this brute force method, and then let's try to figure out how we can optimize it. So what do I want to do? I want to have two while loops. Okay, so nested while loops. So what is the time complexity of this? It's going to be n squared. So for each node here, we potentially have to run each node again. So n times n is n squared. Okay. Now, okay, so I have my head A and head B. Okay. Now, I want to go while. So what happens when okay, so the next is initialized as none. So if I'm here and then I go to the next, then my pointer is going to be at none. So that's how I can know that I have a stopping condition. Okay, so while A, okay, is not none, okay, current equals so what do I want to do? While B, which is going to be here, B is not none, okay, pass. Now, what is A and what is B? So A equals head A, okay, and then B equals head B, okay? And then at the end, once we break out of this while loop, I want to move B forward. Okay, so B equals B, so like this. Next. I'm getting an error there. Okay. Obviously that is not the right syntax then. By the way, I bet you can tell what language I did data structures in. But anyways, so B is a class, so I need to access that member variable by the what is this called? Resolution scope access. The dot operator. That's what it's called. But anyways, so now what do I want to do? I want to say if no, this is not correct. So I want to come here and I want to say B equals head B. Okay, so I start at the okay, so I'm starting at the beginning each time. So I'm going to go A, and then I'm going to start here at this first node, and then I'm going to say, okay, now I'm going to go down the B path and check anywhere in this path, is there this node here? So I'm going to check, and if I get here, well, it's not A. it's not this A1. So then I'm going to move A1 over. Okay, so that means after this while loop finishes, I need to increase A. So A equals A dot next. Okay, there we go. And then B will always start back at the head, right? So I'm going to come here, then I say, here's where I currently am. I'm going to go all the way here. Oh, it's A1 is not in there. So then I'm going to go to A2. And then I'm going to start back up here and traverse again. And say, is A2 in there? No, it's not. Okay, so then I'm going to go to C1. Then I'm going to come all the way back up here. And I'm going to say, all right, cool, let's start traversing. Bam, it's in it. So I'm going to return that C1. Okay, so if A equals B, return A. Okay? Else B equals B dot next. Okay, so what I'm doing is I'm going to come here. So I'm first setting both of them equal to their respective heads. So A1 and B1. Okay. Then I'm going to come here and I'm going to say I'm going to keep going until I visit each of these. Okay. Then what I'm going to do is each time that I visit one of these A nodes, I am going to start at the very beginning at the B. So B dot head or B head. Behead. So then I'm going to continue. I'm going to start here at the beginning at B1 and I'm going to keep going until I reach the end of the linked list. And each time I go here, I am going to check if my current A is equal to my current B. Okay? And if so, I just return that value. So we're going to come here, come here, come here, right? And then and then just return this. So if B doesn't, if we go all the way, sorry, I'm right here at this A2. And then if I check B1 and A2, are they the same thing? No, they're not. So then I need to move B1 over to B2. That's what this does, okay? And I'm going to keep doing that all the way until I get here. Then once I get here, I want to come back up. I reset B to here. Well, okay, first, actually, chronologically in code, what I do is I move A to its next, okay? Then I come up here and start B at the beginning, and then go here until I reach there. So now, if we are able to traverse our A all the way here to the end, so now A is equal to none, well, there was no intersection, so what do we do in that case? We return none. Okay. Let's run it. Let's see if it works. I wish it would tell me though, like, this is one of those things that I kind of have a frustration with Leetcode about, is I understand that it's not optimal in time. I understand that. We stated that at the beginning of this video, and I want to find out, is my algorithm correct anyways? Like, I don't want this time exceeded thing. I wish I could have some way to say, like, yeah, it's correct, but you're not doing good in your time efficiency. You need to change that. I mean, technically I could do the run, right? It passes all the test cases. I'm going to assume that I did my algorithm correctly. So now we need to figure out how to optimize this. Okay. So can I use like a set, like visited or something? Like, what if I did something like this? Like, let's get this out of here. So, what if I did something like this? What I'm thinking is, I'll explain my logic first. So, I think I'm going to come here and I'm going to add A1 to visited. Then I'm going to add A2 to visited. Then I'm going to add C1 to visited. I'm going to add C2 to visited. I'm going to add C3 to visited. I'm going to add all of these to visited. Okay, all along this A path. Then I'm going to go to B and I'm going to say, is this in visited? Yes or no? If no, I'm going to go to the next one. Is this one in visited? If it is, or sorry, if it's not, because it's not, then I'm going to go to the next one. Here. Is this one in visited? No. Okay, then I go to the next one. Is this one in visited? Hey, it's in visited. We return this one. So in this case as well, we're always going to hit the first instance where both of them share, because all of these are going to be in my visited. And then the first instance where I hit a visited, that is the first shared node. Okay, so let's visited equals set, okay, while a is not none. Okay, so we're gonna, and what's the time complexity with this? Well, it is O of n, right? Because we are looping through this one time, and then we're looping through this one time. Okay, so we're doing an in operation plus an in operation. So in plus in is equal to n. So let's code this out. So a, so visited, we're gonna go through all of these and add it to our visited. Visited dot add a. Okay. A equals a dot next. Okay. Then what we're gonna do is while b is not none, if b in visited return b. We just return that b. Otherwise, b equals b dot next. Okay. If we exit out of this while loop, we know, hey, we're done. We didn't find any intersection. So we just return none. Here we go. There we go. Awesome. Awesome, awesome. All right, well, thank you guys so much for watching this video. I hope you enjoyed it. I hope you learned along with me. I hope you got some new exposure to whatever you are struggling with or trying to learn or whatever purpose you clicked on this video for. I hope you got it. If you like the video, subscribe. That would be amazing. I make Leetcode videos every single day. Haven't missed a single day in like 3 months now, so I'm gonna keep this record going. So we're gonna continue doing Leetcode. If that interests you, subscribe. If not, that's okay as well. But I hope you have an amazing day. My name is Timothy Lee Grant, and I will see you guys tomorrow. Yeah.